Forecasting is projecting how the remaining work on the project will be done, time-wise and cost-wise. The forecast shows how much the project will have spent by the time it finishes. Now, when the project manager is forecasting, do not consider it just some calculations. It requires looking at and reviewing current progress and variances, factors that cause those variances, and expected performance for future work. So think of it as a review of issues in the past and current ones and the pending risks. The total expected money to be spent by the time project finishes is called Estimate at Completion or EAC. Ideally, if everything goes exactly as per the baselines, EAC equals BAC. But it would be rarely the case. So the project team has to forecast EAC. Now EAC, the estimate at completion, or how much total the project will spend by the time it ends, has two components. How much has been spent till the status date and how much will be spent to complete the remaining work. So it can be written down as EAC equals AC plus ETC. The actual cost of the work completed until the status date plus estimate to complete the remaining work. In this formula, AC is already known, so ETC is the forecast part. How can the project team determine ETC? For that, there are four common ways. The first, most common among those, is bottom-up estimating of all the remaining work. This will be manual estimation and it will take time, but will also be more accurate than the other methods. So in this first case, EAC equals AC plus new bottom-up estimate for remaining work. If more detailed quantitative risk analysis was done using various risk scenarios, the EAC calculated this way can be a good comparison with the EAC from those risk scenarios. The other three methods are quick methods, as they use cumulative CPI and SPI. Cumulative CPI and SPI are the overall indices for the baseline. The individual activity or work package indices are not used for analysis. So these three approaches are based on the same formula. EAC equals AC plus ETC, where ETC is the forecast. We can also say ETC equals remaining work divided by expected efficiency. Remaining work equals total work minus work completed. Total work is defined as BAC and the value of the work completed is EV. So ETC equals BAC minus EV divided by efficiency. See, both BAC and EV are known. So then what is the forecast in the formula? Only the efficiency is the forecast. And that is what the three methods give us. How efficient will be the project to complete the remaining work? Method 1. Remaining work will be done at the budgeted rate, the planned rate, as per the original plan. So what is the efficiency as per original plan? What is the CPI and SPI as per original plan? Or if we follow the plan, CPI and SPI are 1. So the efficiency is 1. In the formula, ETC equals BAC minus EV divided by 1, or simply BAC minus EV. This approach is usually taken when the overall estimate and spend rate is very good and realistic. If the CPI or SPI or both have deviated from 1, it may have happened due to an issue that set the project back, but otherwise the estimate is good. For example, a training session is going on as per schedule, but right in the middle, the projector bulb blew up. It took a couple of hours to replace and get going again. So the overall estimate was good, but one setback has dropped the SPI or CPI or both. Method 2. Remaining work will be done at the current rate of progress, at the CPI rate or at the SPI rate. Though any of the two can be used, I have always used CPI and I have not seen or heard anyone using SPI for this forecast. This method is used when the overall estimate is too optimistic or too pessimistic. Activity after activity and work package after work package, the CPIs are seen close to each other, resulting in a cumulative CPI that matches them closely. What it means is that the performance for future work is very likely to be following the same rate. So if 10 topics are to be covered in training where each topic was to take 2 hours to complete as per plan, 5 topics have been completed where each took about 3 hours to complete. What is expected for the remaining 5? That those will also likely take 3 hours each. The overall estimate was too optimistic. The cost to complete to each topic is higher. So the formula looks like ETC equals BAC minus EV divided by CPI. Method 3. Remaining work will be done at the combined rate of current progress. This method is used when schedule performance impacts the forecast directly. For example, work finished earlier saves money and finished later results in more funds spent. The combined effect does not need to be 50-50. It can be 80-20 or some other ratio. The formula is ETC equals BAC minus EV divided by CPI and SPI. So using these 3 methods for the post-installation project, the forecast will be method 1, ETC equals BAC minus EV, or 100 minus 35 gives us 65. Method 2, BAC minus EV divided by CPI gives us 74.71. And method 3 at 50-50 gives us 63.85. This third method will not apply in the post-installation case because there was no time impact on money spent the way I described the case above. I just wanted to show what the numbers will look like. Once EAC has been established, the variance at completion or VAC can be determined from the formula VAC equals BAC minus EAC. The variance at completion is the difference between what was originally planned to be spent and what is the current forecast of total spend on the project. Same way, percent VAC equals BAC minus EAC divided by BAC times 100. Percent variance is how much variance is there from BAC percent wise. So this is forecasting using the earned value.